Good afternoon. My name is Eric Mucklow at headquarters of the U.S. Army Corps of Engineers. Welcome to the Sustainability in Energy webinar series. Today we have daylighting and lighting controls. This presentation will discuss current daylighting and lighting controls design standards and requirements, how to meet these requirements with existing technologies, and how to fill out the lead forms for daylighting and lighting controls on your various projects. Speaking with us today is Shenouda Bolos. He's a professional engineer and an electrical engineer with the U.S. Army Corps of Engineers Seattle District. He's been there since 2009, where he's prepared electrical and communication designs for new facilities and to repair existing construction. And he provides technical expertise and guidance on lighting systems as a part of his duties as the RTCX lighting lead. With that, I will discuss with you how to get your CEUs for those of us architects who need CEUs and learning units rather to maintain our licensure. We do these in batches of 5. You can download a quiz from the website shown on the screen, our quote-unquote Mercy site. Fill out the quizzes and email them to the website on the screen, the email address at the bottom of the screen there, s_e webinar, all one word, at usace.army.mil. And presuming you get the answers correct, you'll get your CEUs registered. With that, I will turn it over to Shenouda Bolos.
Good morning, everyone. This is Shenouda Bolos. Thank you, Eric. Today we will talk about two main topics, the daylighting and the lighting control. The daylighting, we will talk about definition, standards, lighting methods, and how to fill the form. As well, we will do the same topic for lighting controls. Start with the daylighting. The daylighting, from the definition, you can see it here in the first part of the slides. It's basically an open in the wall or in the ceiling or using a mechanical equipment to provide the natural lighting inside the building, to allow the daylight to enter the building. The question here, any designer will ask it, why shall we consider the daylighting in our design? Why? The benefits is reduce energy. Most of our lighting energy is used about 70% during the daytime. Also to improve the productivity, to meet the standards. In UFC 3-5330 went in details, which you can see that in this section here, is 4.1. And I will highly recommend everyone to read chapter 4 because it went over all detail of the daylighting. But for the summary of this, for the presentation today, we will go over the summary of that chapter. Go back again to the benefits. They went over the benefits. First thing they said it will reduce energy. And after that, it will be more healthier for the occupants. And also, like for example, they said it will help the children to learn more. At the store, they will be able to sell more. At work, they will be able to be more productive. The worker will be more productive. So back to the idea, why we do the daylighting is the daylighting is not only the energy saving, it's to make the user more productive and more happy. So it's just not just to energy, it has a big picture beyond that. Going to next slide. The requirements, UFC. The UFC 1-200-02, the high performance sustainability building requirements. Section 2-6.3, it's basically ask us to follow ASHRAE 189.1, Section 8.4 or Section 8.5. And after that they said follow UFC 3-5330-01. And then they went again in Section 3-6.3, they went about the strategy how to meet that. They said achieve a minimum of the daylighting illumination level of 25-foot candle and a 50% of the of regular occupant space. This is the requirements. We have to meet it as a designers. Then we will go next slide. Let's go over the ASHRAE 189.1 requirements, the 8.4. We will talk about 8.4 and 8.5. 8.4 is basically if you don't have any designer in your team, if you don't have the electrical engineer designer in your team, you don't have someone who will do the daylighting modeling, how we can approach the daylighting requirements. They said you could do it easily by like if you have any north wall or south wall or east wall, you have to have 75% of the length of this wall have a window or open area to allow the light getting in. It could be a little bit tricky because sometimes some of the rooms does not have easy access. Then ASHRAE 189.1 went in like to make it easy for the designer to meet that requirement. They said you can use the daylighting simulation. You can do build the model, and you don't have to follow the 8.4. You can follow 8.5 instead 8.4. And the requirement is more, and if you have a model, you're going to have accurate result because you're going to have run all simulation, and you're going to have like accurate result how much daylighting in each occupant room. And here they went in details and say the requirements. The requirements, you have to meet 30-foot candles for any occupant room, and you have to meet to get 75% of the area of the daylighting area. What does that mean? It's easy. It's basically if you have the building 10,000 square feet, you have only occupant area about 5,000 square feet. You need to get 75% of that 5,000 square feet in order to meet ASHRAE 189.1. That's the requirement. And they went over the simulation shall be done using either the CIE overcasting sky model or the CIE clear sky model. And then we will go on other requirements. Next slide. These are the most standard we will talk about. We talked about the UFC, the ASHRAE 189.1, and we will talk a little bit later on also UFC 3-530-01. Before we talk about like how we can get there, basically applying different methods for the daylighting. But before doing that, let's understand the two most important definition about the daylighting strategy. First one is a passive daylighting strategy. What does that mean? That meaning is any strategy require to be stationary, like it does not require any mechanical equipment, like windows or skylight. The second part, active daylighting strategy. What does that mean? UFC went in details and tried to answer that, and I have the summary of that. It's basically any equipment or any method or any type of strategy you will use it for getting the daylighting inside your building will require mechanical equipment, like solar shading system, light tubes, and other methods. And we will go one by one in next slides. How to accomplish the daylight. We will talk about the methods, but also how we can get there. It has to be like working in a team. At least the main members are the architecture engineer, electrical engineer, and mechanical engineer. Why? The architecture engineer, he is the designer, or she is. They are the designer of the building. They will select the shape of the building and also will help for the skylight, as well as they will put the windows around the building. Electrical engineer, he or she will be in charge of doing the daylighting model. mechanical engineer. Why we need mechanical engineer? Because some of the windows and some of the skylight allowed the heat transfer inside the building and outside the building, which will require the mechanical engineer to run the energy model to see how much they needed for the HVAC system. That's why the coordination is a main idea to do any of this method, because it has to get appreciated for all three members. So then go next slide. We will talk about each method of those. First of all, the building shape. Building shape is one of the main factors to allow the daylighting enter the building. We'll talk about two different shapes. Like if you look at the square shape, that's that actually figure coming out from UFC 3-530-01. Look at no daylighting exposed. You can see that here, the legend here, no daylight exposure. So if you look at that, you see there is no any daylight here. Look at how big it is here. It's a large area. How much daylighting around the building is good. But if you compare it to the horseshoe, you can see how much daylighting can have it more around the building. So the shape is the significant impact on how much daylight you can have it around the building. Going to next slide. The building orientation. Again, UFC 3-530 went about why you need to, the orientation of building is a big deal, or a big item the designer have to consider. It says, in order to maximize the daylight, you have to have the area facing north and south is a larger area. If you like look at the other graph, if you have a less area facing south and north, you have less daylight and more heat coming in inside the building. Because if you have more area facing, if we have more area facing south and east, we have more heat coming inside the building. So we will have the mechanical engineer has to deal with more putting HVAC system around the building. Method 3 is a window. The window is one of the common methods to allow the daylighting enter the building. To increase the benefit of the windows, we have to consider two items. The room finishing. If we have a shiny color, we'll increase the daylighting inside the room. The window position. Higher the window, like similar to this graphic here, higher the window is the greater the daylighting enter the building. The next slide. Skylight roof. It's basically an opening in the roof, allowed the daylight light enter the building. How we can increase that? We have to consider two items. First thing is a room finishing, also, or building finishing, because shiny color or a light color will allow the light the daylighting increase inside the building, because there is a reflection will happen, will increase the daylighting. And also the type of the glass. Like we can see, like if we have a glare color or light, will affect the type of glass will have two main components: the glare and light distribution. You can see the two different design here. You can see this building, which is a good design here. You can see its glare color, allowed the daylight, but also not allowed a lot of daylighting, because you don't need more than 5-foot candle in a world of daylighting in any occupant area, because if you have too much light, you cannot use it. You're gonna have to block it. Like looking on the bad design on the right, not a bad design, but it wasn't a perfect design. on the right side, they have a clear skylight. Because of that clear skylight, the user ended up using solar shade to block the light. Some user used the umbrella to block the daylight because they had too much daylight on their cube. They cannot work. They cannot see the screen. So that's why the glass type is a big deal with the skylight. So any designer have to right away working with the architecture if they have a skylight to select the glass type or glazing. That's other term for it. Go ahead, next slide. Solar shading system. So let's go back a little bit about the definition. So basic strategy is windows and skylight. Solar shade, from solar shade and until other method we will talk about it later on, they are active strategies. Why? Because have a mechanical equipment. Looking at the solar shade, there's other, like here, like if we talk about you remember other building, we had it in a other slide. They use a solar shade to block of some of the daylighting. So they allowed to block some of the daylight and allowed some of coming in. Look at that graphic here. Next method is light shelves. It's basically takes the sun, the daylighting coming over here, and then reflected in the ceiling, as you see, the daylight coming here and reflect in the ceiling. And there are two types there for light shelves: manual system and automatic system. The next one, another method of active strategy is a light tube. A light tube is a really great method for a deep space, which meaning if you have two-floor building, and how you bring the daylighting to first floor beside the window. If you cannot meet the requirements by only having the window around the building, what other method you should consider? You should consider a light tube. It's had three parts. You have collector in the top, which is collect all daylight. Transmitter, which is reflect all daylight, and then distributor, which are like similar to the light. You can see it here. That's it, light tubes. You can see it as a normal light here. If you follow my green arrow, I'm just trying to point out using a green arrow for everybody on the conference. In this presentation, I'm using a green arrow to point out to the section I'm talking about. So back to light tubes. The light tubes is a great method for a deep space. Other methods, fiber optical. Fiber optical is basically similar to the light tubes, but it's more efficient. Here we can see that in details. It's more efficient and less light losses, but costs more. And basically, it's collect the daylight on the roof using the fiber cables to transmit the light, and then you have a distributor or the light at the deep space also. Next method. Anidolic system is a similar method to light shelves. Same idea, but it's more efficient and also is designed for specific type of buildings and specific ceiling design. You cannot use it in old design, but is out there. Is another technology you guys may consider. So we talked, up to this point, we talked the definition, the methods, how we can get there, the standard, then the method. And we talked about how much benefit the daylighting could be. However, there is some issue for the designer when they will do the daylighting design. One of these issues, shading and sun controls. How you, again, if you remember the one building I said it wasn't perfect design, that when they had a clear skylight, they have some issue with how much they have much daylighting in some areas. So they have to consider shading and sun control. Type of the windows, the heat and heat gains and losses. If you have a clear skylight like what we talked about it a few slides ago, that clear skylight able to transfer heat inside the building. So increase the heat inside the building. Not only that, and during the summertime, it gets worse. During the winter time, allow some of the heat going transfer out. So the designer have to consider what type of glasses they use it, so they don't increase the heat or decrease the heat. And also meeting the daylighting requirements. Other requirements, energy requirements, to meet the energy requirements, daylighting performance, you have to meet the requirements for UFC. The other one is building orientation. It's a big issue because the perfect scenario, you have the most area facing north or south. But sometimes that's a challenge for the designer to meet that requirement when he or she has a specific area to work, specific site to work around it. This could be a challenge. Building shape, also that could be a challenge because sometimes some of the building is a standard building design. That's something you guys have to consider. So now we will talk about the LEED requirement 2009 requirement. Why we talk about LEED? Are we interested only to gain 1 point? Not only that. There is beyond that. Beyond that, because all requirements we talk about at UFC and ASHRAE 189, which all of us has to meet, LEED 2009 summarize it and tell you can do. You need to meet this item by meeting LEED 2009. Credit IEQ Credit 8.1, you will meet all other requirements. So you will meet all requirements and you gain 1 point. It's the best scenario for any designer. And here, ASHRAE LEED 2009 IEQ Credit 8.1, it says you need to have 75% of all occupant space to have daylight, which you remember if you guys go few slides back, if you go a few slides back at ASHRAE, the requirement for ASHRAE 189.1 section 8.5 is asking for the same thing. So meeting the LEED, meeting ASHRAE 189. And what they said here is went more details. They went over it has to be 25-foot candle and maximum 500-foot candle. Why? Because if you have more than 500-foot candle, you have too much light, so people will start blocking that light. It's not making the occupant more comfortable to have the daylight. They will start to block him by using any type of like shade, solar shade or umbrella like what we saw it a few minutes ago, but they will try to block that light because too much light. That's why LEED specified they went over maximum 500-foot candle. And they said if you want to run a simulation, you should consider two scenarios for 2 specific days. September 21st at 9 a.m. and 3 p.m. or March 21st at 9 a.m. to 3 p.m. There is a website you can download if you're gonna work for your building. If you're building at Pacific side, you don't know what is the daylight at that time, how many hours and all that. You can download that through website. You can get this all requirement. Then you run the simulation. If you have any like software like Relux, even there is a multiple software like 3D AutoCAD Max. There's multiple software you can do the daylighting with it. So by using a software, you can run the simulation to calculate the daylighting. And after you calculate it, by the way, you can see that requirement LEED version 3, which is LEED 2009, have been extended to 31st October 2016. And there's a link here down here you can see. So until 2016, October of 2016, we just have to meet LEED 2009 because there is a new version already out there for LEED, but we don't have to follow that until like some other designer have to follow that project like this version, the new version, because they do it as a trial. But for all other designer, you only follow LEED 2009 until October 2006. So the designer met all the requirements. He already met 75% of the daylighting around the building. So now the time to fill the form. If we're looking at the IEQ Credit 8.1, how we can fill this form? It's simple. Some of you already have done it, but I just will go over it for the people they have not done it. As we talk about it, for this purpose, I use the simulation option 1 to fill this form. Basically, you select the simulation option 1, then you go. They will ask the designer to fill the space by space. The area of it is it's basically Excel sheet attached to that form. You will start to fill this part of it. Then you have to attach a few attachments. First one, you will have to have like a layout of the building with either color coding like what we have here, which is the best scenario, or like a mark or something showing where is non-occupant area and more importantly the regular occupant area. So the lead reviewer can know what this area, where is the occupant area and does have the daylighting. Then you run the simulation, and after that, for this for this building is the battalion headquarters building. We use the IES software to do the lighting analysis. Here is showing, as you see in here, we run 2 scenarios at 9 a.m. You can see that 9 a.m. on September 21st and 3 p.m. on September 21st. And you can see, and then that is like a graphic one, and they have like a few pages of like room by room and what each room percentage. And then they will also provide you like Excel sheet or PDF. And you take all these results, and we're going to next slide here. This is back to the form of the LEED 8.1. You will have the total of regular like total space around the building, which was 10,000 here, and 9,000 is the occupant area. How we get these numbers? Like easy to put here. You can see it now on the slide, but how we can get that number? Back to the I attach another slides. I attach another attachment with this lead, so it's make it easier for the reviewer from lead to see all my calculation, and also he wouldn't have any question for me, and I can submit it once and done. I attach Excel sheet. That Excel sheet is back, like that is output from the software. It went over space by space. You can see space by space, and told me at 9 a.m., which you can see here, I have 100%. And we have the floor area of this room, which is 103. 100% of that is 103 have a daylighting of this room. And we did that for all entire rooms in this building. And we did the same scenario at 3 p.m. And after that, we used that Excel sheet also to add the daylighting for the 9 a.m. and 3 p.m. and get the average by divided by 2. And add all this area to get the total of 9,423. That's the total area have a daylight. And let's go back to other slides. That's the number we have. And that's the number of the total area. By that is already calculated. The formula will calculate it again for you. Anything in gray as you see it, you have to fill this. You have to fill this. Anything in white is already calculated. Here, this one is already calculated because you filled the other Excel sheet, the attachment we talked about it 2 slides ago. Then you run, like there is, it's called, you click on this button, you run like it takes 3 seconds and tell you if you make 1%. If you have a 95% or more, you can get additionally point, which for this case we had only 91%. We only gain one point, but you could able to gain 2 points. Back again to the daylighting control. Why you want to meet the lead requirements, not just only the gaining 1 point. No, to meet the codes, to have is better for the users. It's also improve the user and also reduce the energy. Now we will talk about lighting controls. That's the second topic. We finished the daylighting, and we will talk about lighting control. Lighting control. We will go over the definition. It's basically an intelligent network system to turn the light on or off, to control the lights. That's how simple it is. Going next slide. Why? The purpose why? Why we need lighting control? Why we need that? Basically here, if you can see it, to provide the right amount of light, where is it needed? And when it is needed. Simple, but more benefits. You're talking details benefits here. For existing building, you could save up to 50% of the lighting energy by using a lighting controls. In a new building, you can save up to 35% of the lighting energy. Improve light levels, reduce the energy demand, reduce the air condition. Why? How we can reduce the air condition? You could have more intelligent system. You can have a light control system integrate with the HVAC system. You can have an occupancy sensor when you enter any room, any office room. You can turn on light and increase the air conditioning running. You could run the air conditioner at minimum probably 10 or 20%. Mechanical engineer know more about that. And then when any person entered the building, the air conditioner should be running in a full speed. Going off the requirement of UFC, the UFC uh, 1-200-02 section 3-6.3, we just talked about that. If you look at strategy number 2, it says you need to have 50% of regular occupants have to have lighting control. You can see that. And UFC 3-530 asks us to follow ASHRAE 90.1, 2007. Let's go over the ASHRAE 90.1, 2007. It says the designer should follow, you should have automatic lighting shut off for any building has more than 5,000 square feet. How to meet that? You could have a multiple option. Schedule, have occupant sensor, or have a control or alarm system send a signal to turn off or turn on the lights. How we can get there? Using one of these methods. Lighting control system, tradition method, which is a normal single level light switch, turning the light on and off. But look at that, because does not have any control. It's just allowed some people to turn on and off the room. Second method is bi-level switching. It's basically breaking the room to zone and allowed different switch, if you can see here, different switch to control some section in the building. The estimated about 23%. And that estimate came from New Building Institute. Going on other method, occupancy sensor. What is the occupancy sensor? It's basically when the occupant or the person or the user entered the room, will turn the light on, and when he leaves or she leaves, will turn the light off. They estimate the energy will save up to 20%. Then they came with a new technology, it's called vacancy sensor. It's similar to occupancy sensor, but they said let the user turn the light on, and when they leave, they turn it off. And they calculated, they found it out, the energy saved increased to instead from 20% to 25%. The dimmer is basically a device to reduce the maximum of the light, and they found it energy saving up to 27%. You can use that as a design. You can, instead some room you don't need it to have the maximum light all day 100%, you can use it at 80%. That's part of the electrical engineer decision and design for his building. Daylight sensor is a sensor. Soon as find out how much daylight you have, sending signal to the dimmer or the light to reduce the light, the amount of light. And they found out the energy saved up to 15%. Looking here, the lighting control and space type. If we like here, this slide we talked about. If we back to like if we look at the previous slide, we have 6 methods. Which one we should use it for any space? How we can decide which one you should use as a designer? So here, this table show you what option you consider as a designer. For a private office, you should consider occupancy sensor, daylight or vacancy sensor, daylight sensor, dimmer, and calculate energy for all these 3 methods. If you use all 3, you could save up to 35%. For open office, you can use occupancy sensor, vacancy sensor, daylight sensor, dimming, multiple level switch because it's more open area. And calculate energy saving is up to 37. Same thing with a classroom. The estimated with using all different methods, you can have save up to 30%. Go back again to the LEED 2009 requirements. IEQ 6.1. Again, we have the requirement by UFC standards, UFC and standards, and ASHRAE. How we meet those? LEED again, LEED 2009. List all these requirements, have a higher requirements, but it's help you to meet the UFC and meet the ASHRAE requirements. By meeting LEED 2009, you meet all other requirements. You should read it because sometimes you have for UFC and ASHRAE, they have multiple other requirements beside the daylighting, but daylighting and lighting control, they have other requirements. So you have to read the other things. But I'm talking specific about the daylighting and lighting control. The IEQ 6.1 says for any individual room, you have 90% of this room has controls. 90% of all this space has to have controls for all this room. And for multiple occupant space, you have to have 100%. They also add a new here we go, sorry about that. They add how can I meet 90% for individual? How can I give control to every individual and meet 90%? That could be a challenge. But they went in detail and say you could add task lighting. They said task lighting strategy you can consider to include lighting control and task lighting. By having a task lighting in some of occupant space, you provide lighting control. Not a lighting control. Here is providing, you meet the LEED requirements of the lighting controls. So now we understand the requirements. We already have applied some of the method. Now let's go to the slide. Slide 6.1. That's the how we started the slide. And go. IEQ Credit 6.1. The first section of it is called individual controls. You have to have all private office or any occupant room. You have to list those rooms and how many control you have per room. For this reason, for this example, I have 72 room and I have almost 72 controls, again 100%. But it's not required because the requirement is 90%. For multiple occupant controls, for this room, any classroom, conference room, you list how many they are controlled and how you. Then after that, you have some of attachments. Again, you're gonna have attachments showing the layout of the building, the regular occupant area, Then next slide, you're going to have another attachment showing, like for this example, I was just showing 107. We had another attachment which is showing all controls, where you have here daylighting sensor, and we had switch. You have to show that as for the lead reviewer, so he can, when he can run the analysis, he can review your work. Then also you attach a cut sheet for the furniture. If you have a task light, you have to attach that and showing the location of where this furniture was a task light in part of your attachments. Then you get, if you put all that and you meet all the requirements of 90% of individual area and 100% of multiple occupant area, you gain 1 point. Questions? And before question, summarize the daylighting, meeting the lead also help you to meet the all requirements of ASHRAE and UFC. Any question, please?
Okay, this is Eric Mucklow again. I'm opening up a Q&A box on the far right-hand edge of the screen. You should all see it there. At the bottom of that column, there's a text entry box. You may type in your questions in that text entry box, and they will appear in the column above only to me. I will consolidate any redundancies and read them aloud to Shenouda so that he can answer, and it'll be recorded on our recording. In the meantime, also going down, if the boxes on the middle part of the screen now with the Q&A box there, we have the web links box, second from the bottom. We have a link to our private YouTube channel that has our past webinars. Yes?
Eric, sorry about that. I just got a message from ACID Software. It says, will I restart my computer right now? And I will join the conference call in 2 minutes or 3 minutes when I restart. Sorry about that. I will be coming back. Sorry about that. Sometime it happened with it.
Okay. All right. So tell us about these links and things. Until then, I'll look for you to come back online. So let's see here. We have the past webinar videos are on our YouTube channel again. I will have a copy of this video up in probably at least by a week. We also have the new Sustainability and Energy website. Either of these links, you just click on the link and hit Browse To button to go to them. It should launch a new window. That's the Mercy site, not to be confused with our former site. At some point, I suppose we'll stop calling it new. Down below in the file share blank, there's the daylighting and lighting controls PowerPoint presentation that you just saw, so that you can go through that. And I believe there are some websites and things on there if you want to look through some of those that technical information. We have several questions coming. We'll see if we can get Shenouda to answer when he comes back. Let's see here. Okay. Okay. Okay, I think we might actually see if we have of getting some offers of other people who are involved to help. I know how inconvenient some of those ASIT restarts can be. Okay, let's see here. I'm going to promote a couple people, see if they have speakers. The Jeanette or Jared, can you are your microphones working? You enable them, I believe, up at the top bar with that little microphone signal. See, I have a question from Mr. Peterson. Does the simulation software take into account the heat gain associated for the lighting improvements? I believe that our typical energy modeling software does. It reconciles the solar exposure. You have to put in the U values, the windows, and all.
Really? Hey, Eric, Jeanette Fife here. Are you able to hear me?
Yes, I am. There's Jeanette. Okay. And let's see.
Yep. Can you hear me, Eric?
Yes, you're very quiet, though. Can you get closer to the microphone, maybe?
Okay, I will try
This
that. Is
Jeanette
that any
Fife,
better?
NW. Yeah, that's fine. Good, because I do believe we have some other people from NW.
Yeah, can you hear me, Eric?
And, one good thing about working in the Corps is we have a lot of people knowledgeable on subject while we wait for Shenouda to get back with us. Let's see. Basically, I'll throw this out there and see who else. Oh, good. See, have you, Jeanette, have you worked on any warehouse or garage and shop space? There's a question, how do you calculate occupied space? The user logged in as guest, but I'm assuming this means like we have offices that are maybe...
Architects, there's a certain... Hello, this is Jared. Hello, Eric, can you hear me?
Hi there, I hear you now. You're very quiet.
This is Jared, can you hear
Let
me?
me turn up my computer, but... Yes.
Oh, okay. Well, usually occupied spaces are defined by the architects, and they it depends on the amount of people that are going to be in that room, as per the description of the user, and I'm not sure the exact number, but usually the architects have to define those in the beginning phases based off the user's definition of that room and what its intended use is for.
Right, and a lot of times yes, probably in the programming stage, that'd be part of the programming effort, and a lot of times with places like warehouses and things, if they have a lot of times they'll have a bank of storage area, but then they'll have areas that are better air conditioned, climate controlled, and that will delineate what they consider occupied versus non-occupied.
Oh, sorry. Usually warehouses are a little tricky sometimes, just because depending on the users, they sometimes use warehouses as actual spaces for working. I'd have to defer to an architect, but I think having a person there working from like 6 to 4 every day makes it a regularly occupied space. So even though if it's a warehouse, or a storage space, but if the user says that they will have an occupant there or a desk for like an office, then it's gonna be considered an occupied space.
Okay. All right. Let's see here. Let's see this. Is there a source to find out what kind of maintenance some of the lighting choices require, labor versus cost? I know that some in life cycle calculations, we've looked at how often bulbs needed to be replaced for comparing going with LED bulbs versus fluorescent bulbs or other technologies. In fact, the extended life cycle of LED bulbs is one of the reasons that we've been able to justify LED bulbs. Here he comes. Oh, he's back. Wait, where's Shenouda? Where are you on the list? Trying to find Shenouda to promote him to back to presenter. I saw he raised his hand. There he is. There he is. Okay. Sorry about the technical malfunctions here. Okay, Shenouda, you are once again presenter. You may probably have to reinitiate your microphone up in the middle bar there. Are you with us?
Do you hear me now?
Yes, there you are. Okay, we just had a question if there's a source to find out what types of maintenance differences they have in these different lighting choices in terms of like labor or cost of maintenance. Could you hear the question, or are you there?
Repeat this question. Yeah, can you repeat the question, please, again?
Yes. Basically, it's saying, is there a source to find out what type of maintenance some of these lighting choices require? Are there extra maintenance costs?
So back to we talked about the two topics for the daylighting and the light controls. For the daylighting, there is the maintenance requirements for like a skylight. There's a maintenance requirements, and as well like cleaning the window and skylight and all that. There's a maintenance requirement, and that back to the type of the manufacturers, but wasn't in a standard specific says how much maintenance was required for the daylighting methods, and then go specific by each manufacturer for other mechanical one, which is the shader, the solar shading, and all that. It depends on the manufacturer and the type you recommended. For the lighting controls, the maintenance is really basically is the maintenance for any type of switch. There is no any specific document, but I can search in detail about that and probably answer that to you, and you may answer to everybody else on the conference.
Okay. There's one that was touched on a little bit, and this is a bit of a follow-up regarding the occupied space calculations and things. ASHRAE 189.1 gives the sections 8.4.1 and 8.5.1. I don't expect you to have it memorized. But it says office and classroom spaces. As an example, if I have a non-office occupancy such as a mechanics workshop, am I to assume that ASHRAE 189.1 does not apply to that example by way of the High Performance Sustainable Building Memorandum of Understanding are written to apply to offices as well? So I guess they're saying that does the standard for ASHRAE 189.1, I'm not familiar with those sections, does it apply to mechanic shop workspaces and things? Oh, and he follows up and he says UFC 1-202. Yeah, UFC 1-200-2 3.63 Strategy 1, define regularly occupied spaces. Is that the same for lead? Unclear. I'm not sure that is a question really. That's more like a policy question, but
the read requirements, like here is a decision between, again, the architecture engineer and the electrical engineer, because the architecture engineer who is the define what is this room is type. If it's an occupant room, then it's become requirement for lead to be that room is occupying, and you have to meet all requirements for the daylighting and lighting control. If the architecture define that occupant, then there is a different definition how you go, like if that mechanical room is occupant area or not. Like any core room, like electrical room, mechanical room, all that, those, they are not occupant space. A mechanical shop work, like if you have a workshop, Most likely, because you estimate that like the workshop basically is an occupant area, because the architecture defined that as a occupant space because there is more area, like the plan they have more worker will use this area. Mechanical shop, it depends about the defining that mechanical shop area. We have to look at in details how you define that, because if you define it as a mechanical room, then you don't need more worker. But in mechanical shop, like workshop area, it will be defined as an occupant area.
Okay, and now I know that it's probably something that the PDT, the design team, will really have to look at, because there are a lot of different occupancy kind of issues with different standards, and they may or may not be all the same. So it's a good thing to look for the consistencies. So basically, let's see. There's somebody that asked about the past webinar videos. There's a little green arrow on the screen there. If you see that box that says web links, it says past webinar videos. If you click on that with your mouse to highlight it, then you click on the Browse To button. It'll take you to the web page. If that doesn't work, then you can click on that box next to the Browse To button and do Control-C and copy that to your clipboard and paste it into the address on your browser. Okay, let's see. Someone asked if you guys have been, if on the projects you've worked on, if you've gotten any pushback on using light tubes or skylights from the users at all, or have people been happy to use the and not needing
the bigger when we try to use the light tube and other like fiber optical methods, we will find the challenge of proving is a cost effective for the user, because it costs more money. Then you have to show in the cost effectively over 40 years for the lifetime of the building. For the maintenance, is like if you're gonna use any technology, like similar with any even like occupancy sensor, we have to list kind of like we have to get the user to be familiar with that product in order to appreciate that product and use it in the future. So that's we like doing education presentation for them, explain that to the user, which is like sometime like the base. You go to there and to DBW explain that requirements, and that's mostly is always in ASHRAE design meeting, and that's where we brought all this technology we'll probably consider to use it and educate the user and get him to familiar with it and understand it. But the biggest pushback we found it is the cost effective. If it's not shown as a cost effective over 40 years, that method might not be cannot be used. That's the biggest pushback we find.
Okay. Now, with regards to the preliminary stages of design, will following the standard UFC 1-200, the -2 sustainability, will it catch all the requirements when designing the concepts, or do they need to turn to the 3-500 UFC to coordinate it in the preliminary design? Or does that follow later?
This question is very good. It's follow later, but if the designer have been planning and have been working on other project and he knows he would use this kind of like the requirements, if he can bring it early, it's better for the user and the BDT members. But if he cannot, he can bring that later on when the full design start. But they try to follow in the ASHRAE what if you have any technology you plan to use it or you interest to use it, try to bring it up as early as possible.
Okay. Are there references or sources that you would recommend from the information in this PowerPoint? A user would like to use these things and showing how natural light improves productivities for their own presentations where they are.
they are, we can, like some of these parts is like looking online and also as well as finding the actual resource from the manufacturer and technology we have used it in the past. Any user, if they have that requirement, please feel free to contact me. You have the copy of this PDF, you can use it, and if you specifically need detail for one of this technology, please, or method, please can email me directly and I will be happy to provide it to him or her.
Okay. But you don't have a cited work slide or anything like that?
We have used one, yeah, we have used a few of these slides for some of the ASHRAE meeting. I will look at those slides and I will be happy to send it to everyone, but I have to check with the BM as well as the lead person before distribute that slide to everyone.
Okay. Another question is, are the military services establishing glare standards for different types of military building ceilings when using daylighting and skylights for rooftop security concerns? Let's see.
Eric, did you finish the question?
Yes, I said, are the military services establishing glare standards for different types of military buildings ceilings when using daylighting and skylights for rooftop view security concerns? I'm not sure actually I follow that. Rooftop view security concerns, although the person stated that they had to leave, so I guess we can't elaborate. Rooftop view concerns.
So, so there is a, for you.
Yeah, I don't know if unless you know what he's talking about, I can't really guess. Rooftop views for security concerns, I guess he's talking about somebody looking down the skylight. I'm not sure what he means by that. Not necessarily a glare issue, but I think we might have to skip that one. Back to one, I kind of addressed that earlier. I know our energy modeling software reconciles it, but the software and the tools that you referenced, do those simulations take into account the heat gain associated with the lighting improvements? I assume he means greater window areas or rooftop window areas. I know that's always a trade-off between the light gained in the reduction in electric light versus the additional HVAC load from the solar heat gain.
If the electrical engineer used the IES software, which is basically energy model software, that's where some of this calculation of the daylighting could be captured and mechanical engineer can run some of the simulation. But sometimes it's really hard when only we're doing the daylighting by itself or doing like in a different software like Relux or some other software. So only thing we can coordinate it is a type of glass and try to, based on the research papers or the manufactured cut sheet, we can figure out how much heat transference the building, and then we can go from there. The mechanical engineer can go from this point.
Okay. All right. Last comment that we have is a great presentation. I certainly agree. Apologize to everybody for the technical difficulties we had a little bit there. And thanks for Annette and Jeanette and Jared for stepping up to answer some questions also, at least as best we could. Thank you all. We're a little bit over time, but I hope it was worth the wait, and we will see